Yo, what's up? Piwaki here, and today we're taking a look at part number 2 of the FreeCodeCamp Data Analysis with Python projects, Demographic Data Analyzer. If you enjoy the video, make sure to like, subscribe, and comment your favorite thing, or how I can improve my code. So I've previously tried to record this video, however, my resolution was off like in the last video, so we're just going to do a quick run through of all of the tasks that we're required to do for this project. So there's replit starter code, we'll get into that in a second. And let's read the instructions. In this challenge, you must analyze demographic data using pandas. You are given a data set of demographic data that was extracted from the 1994 census database. Alright, so the data looks like this. You have age, work class, FNL, I don't know what that is, maybe just like gross income, but I have no idea. Education number, marital status, occupation, relationship, age, sex, and on and on. You must use pandas to answer the following questions. I can read these questions here, they'll show up in the other, in the actual project file, so we'll see that there. So use a starter code in the file, demographic data analyzer, so we'll look at that. Update the code, so all the variables, okay, yada yada yada, and there are unit tests. So let's go to the tab and let us run. So we're running the main.py file. We'll check the console very soon. And it's going to take a little bit, so I'm just going to open all the files required. See the README, it's just the, shows instructions and it's just the starter code. So before we ran 10 tests in 20 seconds. Okay, so we passed all the tests, which is fantastic. And before we get into the video, if you're making this project right now in 2022, I don't know how long this has been an issue, but click this 3 dots, show hidden files, go to replit.nix, and you're gonna need these, at least for all the projects. For this one, you really only need pandas, but all these should be imported for all your Python projects here in the when you're given this replit starter code. If you don't have this, let's say we delete this line, we're gonna get that a module not found error. And it's gonna say pandas is not found. What? Okay, I thought it would say that, but apparently it didn't. I guess it was once you put it in, it's built in to the packages. But just make sure you put all these dependencies in the deps list. I'll put this text in the description for you to see, or for you to copy and paste into your own deps list. So let's go to the main file where we write our code. Let's get rid of the console. And so, I mean, the main file, we just import. I mean, this is all just starter code. There's no reason to change any of this. You're not even supposed to. This is the file that we want to change. So, don't worry about this right now. We will look into that later. Let's start with the calculate demographic data. So we have this CSV file here, which contains all the data. So there's about I think there's 30,000 lines of code or something or 30,000 lines of CSV information here to parse. So we're making a pandas data frame, say pandas read CSV, simple enough. All of these used to be set to none. So df was set to none, this variable set to none, this, and a bunch of other things were set to none, and you had to change them. So we're gonna read CSV, built-in pandas function, and we're gonna read the adult data CSV file. First question: how many of each race are represented in this data set? Should be a pandas series with race names as index labels. So I'm gonna define the race count of pd.series, and here we're going to say this is a way to check, or we're doing enhanced looping here. So for every unique race in the data frame, we want to say df race, if the race equals the current race, we could also say something like this. We could also say, I'm just going to use dot race equals the current race, so it's a enhanced for loop. So for each race in the unique races, we just want to sum all those occurrences, and then that will be the corresponding index of the of the corresponding race. So for example, you have white first, so the white race first, and it counts all of those, and then it'll put, technically it's going this way, so the white race will be here, and then it'll say how many people are in the right white race, and it'll kind of go based off of that chronological order. So this will return a series. And then we need this indexed argument because it says with race names as the index labels, so we want the unique race names as the index labels. Oops. Alright, and then the second question was average age of men. So the average age men equals round df locate, and so we're supposed to round to the nearest decimal place. Where does it say that? I forget where it says that actually. Oh, round out decimals to the nearest tenth right there. So that's what we're going to do with round and a final argument of 1. So we're going to locate all the elements where the sex is male, and then we're going to get all the ages and then get the mean of that. So simple enough, finding the average age of men. Then what is the percentage of people who have a bachelor's degree? So again, it's kind of the same idea here. So we're just going to say, actually this is a bit different. This is not the same idea. So I was doing this percentage bachelor's, and I had said something like this. So look at line 5. So I was saying, let's say it was percentage, or no, what am I saying? That's kind of hard to say. So instead I was saying something like round. I was saying df of where the df of education is equal to bachelor's. Kind of dot count. I was using dot count, and I wasn't using LOC lock, or locate for short. And for some reason that threw a value error. So I kind of found this different way to do it by using lock. I was looking at the Jupyter notebooks given through this course, and I started using lock instead to see if that would help. So I said, okay, in the data frame, locate the elements where the data frame of education equals bachelor's, and then divide that by the length of, or we're going to want the length of where the education is bachelor's. So how many elements are in the data frame, divided by the total number of elements in the data frame, times 100, right? So 100 is for the percentage, and just round to the tenths. Alright, what percentage of people with advanced education make more than 50K? What percentage of people without advanced education make more than 50K? So this higher education and lower education were given as variables. I didn't make them. I made the bool variable. So let's take a look at the bool variable first. So bool, this basically just says where the DF education is bachelor's, or the DF education is master's, or the DF education is doctorate. So I said, okay, for a higher education, we want this to be true. So I said df.locate where the bool, and then you just say bool, then it's going to just say true. And then lower education, we use the same df.lock, but we use a tilde to describe not in pandas. So we're going to say tilde bool where it is neither a bachelor's, master's, or a doctorate degree. And then, okay, now we find the percentage of salary with 50K, so we're answering. This is the second part of this question. The first part is to find the data frame elements of people with higher and lower education. So we're going to say, we're going to use the same kind of length idea here. Higher education rich equals, obviously the round function because it's percentage. And we're going to say length of higher education, not locate. So from the higher education elements, we want to find where the salary is equal to this greater than 50K. So if we see in the adult CS or adult data file, and we see, okay, so we have two types of salary, greater than or less than or equal to 50K, and then we have greater than 50K. So these are the two kind of salary indicators they had, and that was it. So you just had to say it was equal to the string of greater than 50K, instead of usually having it be an integer. So we're gonna find the length of all the people with higher education salary greater than 50K, or yes, yeah, and then divide that by the length of the higher education, so how many people actually have a higher education. Then we multiply that by 100, round to the 10th place. What is the minimum number of hours a person works per week? So this is a very simple command. Just we don't even need to use locate or anything like that. We just say df index hours per week, which will get all the elements in terms of hour per week, and just min. Find the minimum. What percentage of the people who work the minimum number of hours per week have a salary of 50K? So num-min workers, I believe I made this variable. Yeah, I made this variable here. So I said num-min workers. I got the data frame elements where was all the people who worked 1 hour. So this answer is actually 1 hour, min work hours. So that is 1. So find all people who work 1 hour, like that. That's what that does. And then the rich percentage is, we're again using the length. So we're finding from the num-min workers, locate the num-min workers where the salary is greater than 50K, divided by the total amount of the number of minimum workers, multiplied by 100, and we get the percentage. Obviously round to the nearest tenth again. Okay, second to last question. What country has the highest percentage of people that earn greater than 50K? So this one was quite a difficult one. You can see that this is pretty, it's pretty big. It's huge. So I made this variable first, highest earning percentage series, and I made it a series of, it was, so you're looking at me this way. So here are the countries for index, and then here are all the people that are like, for each country, how many people are like rich, right? So, or greater than 50K. So I said PD series round, and then I said, okay, then I'm using a loop here because I want to get the series. So for each unique country, I want to say the df of native country equals the current country that I'm on. So we're saying for country in df.nativeCountry.unique gets all the unique countries. So then we want the native country to be equal to the current country. And then we want the salary to be greater than 50K. Then we want to sum all those elements, all those, wait, sum? That actually worked. I could be using len here, or I should be using len. You know what, that's what I'm gonna, oh, there's so many parentheses, so I'm gonna get lost. Where does this parenthesis go? Okay, so we can say len of this here, and then divided by len df.country. Okay, so this is saying for each native country, find out how many people earn 50K, and then divide that by the total amount of people that are matched to that country. Multiply by 100, round to the down to 1, and then for country in the unique countries. And then the index is going to be the unique countries because we want the index to match. So the highest earning country is going to be from this series. It's going to be the IDX max, so index max. So indexes, we have all the native countries. So you want the index of the max element by percentage, right? And then the highest earning country percentage is just going to be equal to the max. So we have index max, which gets the country, right? The countries are indexes. And then the highest earning percentage series, stat max, just gets the value. So the highest percentage. I guess we're all like that. Final question. Identify the most popular occupation for those who earn greater than 50K in India. So top India in occupation. So we want to have, I basically did it so like checking every occupation. So I did another loop. All this looping perhaps probably takes a lot of time. I think there's probably a better way to do it, but this is the way that I found, and it took like 20 seconds to get all the test cases, so I don't know if that's great, but then again, this data file is huge, so maybe it's not too bad, but I'm not quite sure. So, okay. So we're gonna get a series. Again, we're using len here. Or some, I mean, but I'm gonna use len. Keep it all the same. So the length of the number of elements with the native country is India, and the salary is greater than 50K, and the occupation matches the occupation for each occupation in all the unique occupations. So it's a bit of a mouthful, but I think the idea is clear that, okay, we're finding from the data frame where country is India and the salary is greater than 50K, and the occupation matches the occupation for each occupation in the list of occupations. That's really a mouthful. So that makes a series, and then at the last parenthesis of making the series, we can call that IDX max, and we'll get the correct value. So I made a couple changes. Let me make sure it still works. Oh, wait, I don't think it has. Highest percentage of rich people in country, 100%. Must have done something wrong. You know what we can do? We can just do this. We can just undo, oops. We can just undo what we did. Oh, just get rid of this. For some reason, len works sometimes, and I guess some work sometimes. I thought they'd be the same, but maybe not. Okay, I believe these are all the correct stats. Let's just see and make sure. Alright, so we got the test passed. I don't know if I had some parenthesis mistakes or my lengths were wrong or something. I don't know, but I guess sometimes I have to use some and sometimes I don't. I don't know, it's a bit confusing for me even. But overall, I hope you understood this project recap. Let me know in the comments if you have any questions. Thank you very much for watching. I hope you enjoy the rest of your day. Peace!